Hello, welcome back. Today we're going to talk about average rate of change. What is average rate of change? Well, let's talk about what is rate of change. So when it comes to a linear function such as y equals to mx plus b, so the rate of change is going to be the slope, right? That gives you, hey, every time when you change x, how much y is going to change. Well, in the real life scenario is such as hourly pay, right? Such as you getting $20 per hour, so that would be your rate of change. So which means you work extra hour, you will getting every extra hour that you're working in that for that company, you're going to get extra $20 for your pay. Or a car can drive 27 miles per gallon. This is also rate of change. And a population of rats increases by 40 rats per week. That's scary, but yes, that's also rate of change. All right. So what is average rate of change? Because in a graph, think about in graph. You've seen different graphs right now. Sometimes we have parabola. Sometimes we see these reciprocal function graph, which just look like this one, oops, and this one, right? So they're not a straight line. So for every given 2 point, how do I find their change, the rate of change? Because they're curves, so that means every section they're going to be different. So when it comes to average rate of change, that means between two input value in the total change of the function value, which is the output value, divided by the change in the input value. So that's the definition of average rate of change. The idea is similar to the concept of a slope. In the difference is, for slope, every section that you have is going to be the same. Okay, I'm going to show you later. Let me write down what is the definition of average rate of change. So average rate of change is between the two input values is the total change of the function value. Which is the output value divided by the change in input value. So in a formula, this is going to be average rate of change. Sometimes you see something they write like that. Sometimes they just write average rate of change. This is acronym equals to the change of output over the change of input. In math, we use delta, the change of y over the change of x. So again, this is very similar like slope. It's going to be y2 minus y1 over x2 minus x1. Okay, so what does that mean? If I give you a graph, you will get it. So this is a linear function. If I given you any two input, like in 1 unit, okay? So the distance between this is 1 unit, let's say 2 unit, or it doesn't matter, 1 unit. So that means in any given 1 unit, this slope is always the same. If this is 1 unit, or if this is 1 unit, so the slope of this part, they should be the same, right? But when it comes to when it comes to a parabola, it's going to be different, because in this 1 unit, the slope is flatter than this 1 unit, right? Here is another 1 unit. Oops, I don't have enough space. I need to go further. So as you can see, the slope in here is changed. It's going to be bigger because it's more steep. So that's the differences. If it's for non-linear function, the slope or the average rate of change is going to be different. When it comes to slope, for every average rate of change, they are going to be the same, which is equals to m. Okay, so how does this work? Remember, this is similar to slope. It's just y2 minus y1 over x2 minus s1. That's how you define the slope. We just apply this to a nonlinear function. So for example, using the... So here's one example. Let's take a look. So on a road trip, after picking up your friend who lives 10 miles away, you decided to record your distance from home over time. Find your average speed over the first 6 hours. So what's the average speed? So now remember, the distance is how far away that you are from the place that you left, probably your home. Okay, so hence your average speed is the average rate of change. Average rate of change, ACR. Okay, so you traveled how long? In 6 hours. So for 6 hours, you travel from 10 miles to 219.2. So that means within 6 hours, your travel distance, your total travel distance should be 219.2 minus 10, which is 218.2 miles. And then what's the travel time? So since you travel 6 hours, so your travel time is going to be 6 minus 0. So your average rate of change, which is your average speed for the first 6 hours, is going to be 218.2 over 6, which is equals to 14.7 miles per hour. Oops. For your first 6 hours, okay? But your average rate of change could be different, because now let's try to calculate, hey, how fast you drive for the first 2 hours. Well, for the first 2 hours, you are driving how many distance? Well, the distance is going to be 90 subtract 10. So you totally drove 80 miles within 2 hours. So for the time, it's equal to 2 minus 0. So this is 80 over 2, which is 40. So that means in the first 2 hours, you're driving 14 miles per hour, which is slower than the first 6 hours. So take a look. Your average rate of change is going to be different. The first 6 hours, you're driving 14.7 miles per hour on average. But within the first 2 hours, that after you pick up your friends, you were driving 14 miles per hour. So in the notation, the average rate of change is equals to f of b minus f of a over b minus a. In a sense, this is similar to y2 minus y1 over x2 minus x1. Okay, so let's compute the average rate of change of the function x squared minus 1 minus x on the interval of 2 to 4. Oh, I should including 4. All right, so when you take a look at that, what is average rate of change? Again, is y1 minus y2 over x1 minus s2. Or our s1 is what? S1 is 2, s2 is 4. If you want to say, okay, I want to say something in here. First of all, y1 minus y2 over s1 minus s2, they equal to y2 minus y1 over x2 minus s1. These two are equal. You can put whatever number you want to be in front, as long as they are the same. If you decided to y1 to be in the front, so s1 has to be in the front. If you decided y2 has to be in the front, s2 has to be in the front. Okay, no matter what you choose, if I decided, hey, y1 minus y2, s1 minus s2, that means y1 is what? Fx x1 minus y2, which is f of x2 over s1 minus s2. Okay, so in this case, s1 equals to 2, s2 equals to 4. So I have 2 minus 4 for the denominator. The numerator should be f of 2 minus f of 4. Okay, so now let's find out f of f2 and f4 equals to what? Since our function fx equals to x squared minus 1 over x, so f2 equals to 2 squared minus 1 over 2, which is 4 minus 1/2, which is 7/2. And then f of 4 equals to 4 squared minus 1/4, which is 16 minus 1/4. This is equals to 16/3 over 4. So now let's calculate the average rate of change from 2 to 4. So the average rate of change from 2 to 4 equals to f2 minus f4 over 2 minus 4. f2 equals to what? 7 over 2 minus f4, 3 over 4 over 2 minus 4, which is negative, the top is equal to negative 49 over 2 over 4. Please calculate that by yourself. By now, you should be able to do this fraction operation. I'm not going to show the detail in here. This should be negative 2 in the bottom. So negative and negative, they cancel each other out. So I will have 49 over 8. This is not hard, it's just a fraction computation. You will be able to do that. If it's not, please go to review how to do a fraction operation. Okay. So now we have been using a number for the average rate of change. So what if we use letter? So if I want you to find the average rate of change of this function, g of t equals to t squared minus 3t plus 1 on the interval of 0 and a. A letter A. So your answer will be an expression involving A. That's okay. Don't freak out. It's just a letter. Okay, so what's the formula? Well, the average rate of change formula should be g of 0 minus g of A. Oh, we've been using y1 minus y2. So that means in the bottom, we also use x1 minus s2. Or you can use ga minus g of 0 over a minus 0. Either one is fine. So since the previous example, we already used y1 minus y2, in this case, I'm going to use y2 minus y1. Okay, so in this formula, this is the formula of average rate of change. We need two things, right? We need to know g of a equals to what and g of 0 equals to what. So g of a, well, g of t equals to c squared minus 3t plus 1. So g of t should be what? You substitute every t with a, okay? So g of a is equal to a squared minus 3a plus 1. Easy. You don't need to simplify in here. That's it. And then we also need to know g of 0. Well, we substitute every t with a 0. So I have 0 squared minus 3 times 0 plus 1. So I have 1. So the average rate of change equals to GA, which is a squared minus 3a plus 1 minus g of 0, which is 1 over a minus 0. Now we need to simplify it. 1 minus 1 gives you 0, a squared minus 3a over a. Well, they both have a, so that means we need to simplify it. So you eliminate 1a out, so of a minus 3. So this is average rate of change. We can also get average rate of change from a graph. For example, if I given you a graph like this one, I want you to find the average rate of change. Oops. On the interval from 1 to 3. So how do you do that? So again, we use the formula average rate of change equals to f of 3 minus f of 1 over y3 minus 1. Remember, f of 3 is what? y2 minus our y1, right? Okay, so f of 3, when you look at the graph, when x equals to 3, fx equals to what? Fx equals to 1, right? When x equals to 1, fx equals to negative 1. So remember that when you write this term, f1 equals to negative 1. So that means I want to subtract a negative 1. Not subtracting 1, it's subtracting negative 1. And then 3 minus 1. So I have 1 minus negative 1, which is 2 over 2, which is equal to 1. So that means the average rate of change for this graph from 1 to 3 is equals to 1. Okay, so that's it for our average rate of change. Next time we will talk about the behavior of the graph. See you next time.